Hi, this is Dr. Pan recording from Tucson, Arizona. I hope life is treating you well, and thank you for watching this clip on digging out roots of polynomials. We have a lot of questions regarding this topic, and I thought I would make a two-part video series on what are the roots of polynomial and how do we really dig out. Whenever I think of roots of polynomials and digging the roots out, I think of truffles. Truffles are among one of the most expensive nature food. Costs anywhere from $1,000 to $2,200 per pound for white truffle. Even the black ones goes anywhere between $300 to $600. And I thought, that's a good analogy for digging out the roots. You might be wondering, what are the roots of polynomials? Well, let's talk about it. So, in this part 1 series, I'll give you what are the roots, okay? And that gives you, hopefully, answer the question why we care in the first place. And then we'll talk about how we dig out, how we dig out roots, okay? And then here, I'm going to use the computer scientist's analogy. There's a whole bunch of loops we'll go through, and I'll go through it and why we do it and how we do it. And then using this example we were given here, I think it's a pretty good illustration of this typical problem. What are the roots and why do we care to dig them out and how do we dig it out? So let's address the first part. What are the roots? Now here what I have is using the Wolfgram as a computer aid, and I went ahead and plotted out this function where we're to find the roots. Roots are actually just a fancy word to see where is the function. Here's the function as in blue. This is the curve. This is the x-axis. Where does the function cross x-axis? It has to be x-axis because we're really looking for the special values such that this x, where it crosses the x-axis, when you plug into this complex function, you end up with a 0. Okay, that's what we call the roots. So here are the roots, or the truffles, or we call it zeros, or in our case, we think it as truffles. Okay, so how do we dig out of those truffles? Well, first one, you got to know what they are and why we dig them out. Now, on a simpler case, if you are, say, a quarterback over here, you toss the football in the air and you have a receiver here trying to catch it. The distance between them can be modeled, and technically using our analogy here, where can find where the roots are. Now, of course, quarterback get paid $1 million because they can calculate it, and a wide receiver, a human brain can basically calculate how far they have to go. But if you were to write a computer program trying to trying to predict it or model it, this is exactly what you have to do. You find the roots. That's the first example come to my head because my 9-year-old is really into football right now. All right, back onto this one. So we addressed what the roots are and why we care. Now let's talk about how we dig out the roots. Okay, so we have a function here that's a polynomial higher than second degree, so we cannot use quadratic formula. So our goal here, as I alluded earlier, what we need to do is reduce this one by factoring it. So we have something, rewriting this fx equal to something, a simple one, times something else. And because we can factor reduce degree of 1, this one, we're going to degree of 3 reduce down to the quadratic here. Why do we want to reduce to quadratic? Because we have quadratic formula. Then we can use quadratic formula on this. Okay. Now, if you have a 4th power here, you're going to have to redo this again. So basically, you're going to have factoring once, get it to the cube. Let's see if you have a 4th power here. Then you factor it once, reduce down to a cube, and then factor it again, reduce down to quadratic, because your goal is always repeat the process of factoring until you end up with a quadratic with some factors. And why do we use quadratic? Because we have a quadratic formula. We can use quadratic formula to actually find the roots over here. Okay, so in the next few minutes, let's get started solving this one. And when I reach 7 minutes, whatever left over, we'll solve on the part 2 of this problem. Okay, now the first problem is this. We have this big, huge, complicated polynomial here. Okay. In order to solve this one, to find the roots, it's basically looking at a needle in a haystack. How on earth can you find the 3 points out of all the possible numbers that we have? Because the number of digits we have, it's infinite. We have real numbers, we have complex numbers, we have imaginary numbers. Where do we even start? Well, come to our 8 is this little theorem called a rational theorem, or most people probably call it PQ theorem. This little theorem is a lifesaver. The PQ theorem says, look, if I grab the coefficient of the highest power and the constant term, I can guess where possible roots are. Now imagine that. So instead of needle in a haystack, you can have a needle in a, maybe a pencil box, or maybe in a small little cube. Okay, the point is you can reduce number of solutions you have to look for into a set number of solutions. Okay, so this PQ theorem is the first tool we need. The PQ theorem says basically grab the coefficient here, grab the coefficient here, and through some manipulation between this and this, we can actually guess where the possible roots are. Okay, this is where we'll pick up on the second portion of this video series. All right.